All right, we're on. Example 2, y equals 10e to the 3x squared plus 5x. That's the exponent. There's the rule right there. If y equals a e to the u, dy dx is a times e to the u times du dx. So all I have to do is define u equals 3x squared plus 5x, and du dx is going to be 6x plus 5. Now a is 10, so don't forget, we now have to define a also. So plugging it into my exponential rule right up there, dy dx is going to be a, which is 10, times e to the u, okay, times du dx. It's going to be 10 times e to the 3x squared plus 5x, right, times 6x plus 5. Because of the commutative rule, and this is one term, I could put that 6x squared plus 5 anywhere I want. So I'm going to put a 10, 6x plus 5, e to the 3x squared plus 5x. I can now distribute this if I want. I don't really have to, but 60x plus 50 times e to the 3x squared plus 5x, and that's your answer. 10 times 6 is 60x, 10 times 5 is 50. I just distributed the 10. Now, I didn't have to do that unless I told you to simplify. All right, let's take another example. This one's a little bit more difficult. And let's see if you can figure this one out. Y equals e to the x divided by e to the 3x. Now, the temptation is to use the quotient rule. But in this case, why not make it easier on yourself? The exponent is a plus 3x. If I bring it up to the top, it's going to be e to the x times e to the minus 3x. Correctamundo? Okay, now, do I have to use the product rule? Well, what happens when I multiply two exponents like this? I usually add them, right? So I can say this is e to the x minus 3x. So what do I have now? I don't have a product rule. I don't have a quotient rule. I have a straight power rule. So y equals, by the way, I know you don't like the chain rule. Fortunately, this one, you wouldn't know how to use it, even if you did the product rule on this. If you didn't see that, you could do the product rule on this, which is easier than the quotient rule. But here we have e to the x minus 3x. A lot like this one over here. Instead, a is 1, right? So we're going to let u equals x minus 3x, and du dx is going to be what? Well, what didn't I do? What's x minus 3x?
Negative 2x.
Minus 2x. So let's do that first. So now we have u is minus 2x, and du dx is minus 2. So let's go over that again, just in case we confused you. We had e to the x over e to the 3x. I brought the power up, which is 3x, became e to the minus 3x. Well, when you multiply two powers, you add them. Remember when we had x squared times x third? That became x to the fifth. So it doesn't make any difference if I have a constant. So x minus 3x, that is minus 2x. Now I'm going to let u equal minus 2x, du dx equal minus 2. So dy dx, substituting in the rule. The a is 1. Remember, we have to define a. A is 1. We'll look up to the rule here. Times e to the u, e to the minus 2x, times du dx is minus 2. And the answer is minus 2 e to the minus 2x. Now that took about 3 steps. Doing a quotient rule is going to take you many more steps. Product rule is going to take you a little bit more, a little bit less, but this is just really 3 steps. And you're going to get the same answer. If you don't believe me, I advise you to do the quotient rule with this equal u and this equal v, and you will get the same answer. So you see, one thing that you have to do is simplify the function before you take the derivative. Sometimes we can simplify the function using log rules. That's why I gave you the log rules. And we'll do a problem like that. I don't know if I'm going to get to it today. Well, let's do another problem, and this one is something where you have to use the product rule, I think. I'm trying to find my eraser, and there it is. Okay, well, let's do another example, keeping the rule over there, so I don't have to keep writing it. It's in the right-hand corner of the board. So let's take one a little bit harder than before. S of t equals 3t e to the 3t squared plus 5t. Well, what do I have here? I have 2 functions. I have a function, I have u equals 3t, and v equals e to the 3t squared. Let me stand up for it. It's a little bit. 3t squared plus t. All right, so let's do the product rule. So if I want to find the derivative of this, I'm now finding it with respect to t, because t is your independent variable. That's the one that's changing. Well, that's going to be u, 3t times the derivative of e to the 3t squared plus t plus 5t. That's the part, that's first term. Second term is e to the 3t squared plus 5t times the derivative of 3t. All right, now let's see this. 3t stays the same. I want to take the derivative of this. I can call that a. What's going to happen here? The derivative of 3t is 3. It's going to be plus 3 e to the 3t squared plus 5t. All right, so let's look at a. So a is the derivative of e to the 3t squared. Now you want to let u equals 3t squared plus 5t. Du dx is 6t plus 5. And what's a in this case? Well, I didn't have the 3 there, so A is 1. Okay? So, the 3 is outside here. So basically, this derivative is going to be A1, look at the rule over there, e to the u, e to the 3t squared plus 5t times 6t plus 5. I'm going to put this back in here. So S prime t becomes 3t times e to the 3t squared plus 3t times 6t plus 5 plus 3e to the 3t squared plus, that's a 5t, sorry about that, 5t. All right, so let's see what we have here. Well, what do we have common to this? Can I factor out the e 3 to t squared plus 5t? It's common to both. So let's factor e to the 3t squared plus 5t. So S prime t going to equal now 3t. I'm going to equal e 3t squared plus 5t, that's outside. And now it's going to be 3t times 6t plus 5 plus 3. So, leaving this outside, e to the 3t squared plus 5t. The board starts to shake a little as I get down. Distributing this is 18t squared plus 15t plus 3. And that's your answer. You really cannot reduce this anymore. Notice that's a little bit more complex than the rest of them, but I basically use the same rules. Use the product rule, I use the exponential rule within the first term, use the power rule, and here we have the answer. So now what we want to do is go on to some practical problems. I don't have a lot of time left in this lecture, but I will give you the beginnings of the problem. And this is what I'm going to solve. So this is a practical problem. And what I'm given is, it's a revenue problem. The revenue equals 250 times x times the exponent of 1 minus 0.01x. And I want to find the derivative. Yeah, I know, I'm almost finished. Okay, I want to find the derivative. And that's it. Okay, so we're going to continue on Wednesday with this. Okay? And we will finish up 11.2 Wednesday, and we'll go to 11.3, which is implicit differentiation, which is difficult. We'll have to spend some time on that. Okay, I will see you on Wednesday. If you have any questions, email me or join my Google Hangout. I've only had 2 of you join. Okay? You have some questions? Give me a call. Homework or lecture.